Alright, so welcome back. So this is going to be a video going over the worksheet that was recently posted. So I had a few questions about what happens when you add a resistor. Because in the previous video I just had a single resistor and a single diode hooked to the AC source. So just wanted to kind of throw y'all to the wolves per se. Just to see if you could use some critical thinking and get it. So I said that VD and VR2 will mimic each other, and that is absolutely correct. So what I'm going to do is I'm going to go over this, and then I'm going to give another worksheet that is somewhat identical and have y'all redo it. Just to see if you do have a better understanding. And I've looked through some of the worksheets already, and some of you nailed it. But this is just an explanation for the worksheet when you have that extra resistor in the circuit. Okay, so R2 is working as a load. That's our load resistor. Generally, your load is going to be in parallel with your diode, because your diode is what's doing the work of either letting current pass or block. So let's just briefly go through the two circuits. So one with the diode pointing this way, and then one with the diode pointing the other way. Okay? So the first thing that we want to do is we want to just kind of analyze this circuit and see what all we have here. So again, we have an AC source, 15 volts peak. So remember, that is 15 volts peak or 30 volts peak to peak. Okay? So the first waveform that we want to draw is going to be our source voltage. And that is very easy. It's just a waveform with a 15 volt peak in the positive direction and a 15 volt peak in the negative direction, which gives us a 15 volt peak or a 30 volt peak to peak, because the span from positive 15 to negative 15 is 30. Okay? So that's pretty simple. So now let's look at what the other waveforms are going to look like. So first, let's remember what our upswing and our downswings are. So the upswing, remember, this is your polarity. And then on the downswing, that polarity swaps. So this would be your polarity on the downswing. So let's look and see what is going on the upswing. So remember, when I'm talking about upswing, I'm referring to when current is traveling in this direction. So it's traveling in the positive direction on the upswing. Okay, so on the upswing, if this is my polarity, then on the upswing, the anode is more positive than the cathode. So that means that on the upswing, this diode is acting in forward bias. Okay? So the upswing, we have forward bias. And again, that's because the anode is tied to the positive. Now, on the downswing, when this is my polarity, is the anode more positive than the cathode? It is not, because the positive is now tied to the cathode. So on the downswing, we are in reverse bias. So one thing I wanted you guys to try to figure out for yourselves on this previous worksheet is that this is nothing more than what we did in DC. We had the DC power supply here. The only difference is we're looking at a waveform, and also it's acting as forward bias and reverse bias, just depending on whether you're in the upswing or the downswing of the waveform. All right, so let's erase this, and let's look at what we would look like on the upswing. So 15 volts is plenty enough to make this diode lock. So at 15 volts on the upswing, the diode is forward biased. So that means that the diode is going to be 0.7 volts. So if the diode is 0.7, then what is R2? It's in parallel, so it's also going to be 0.7 volts. So if the 0.7 volts is accounted for here, what is left of the voltage is at R1. So that would be 14.3 volts. So on the upswing, if we're looking just at R1, so that means that our oscilloscope is just going to be across R1. That's all we're looking at. So on the upswing, the resistor is going to be 14.3 volts on the upswing. Because on the upswing, we are forward biased, and we're locked at 0.7 here, okay? So let's go ahead and go down here and draw the upswing. So on the diode, on the upswing, we are at 0.7 volts. And since R2 is in parallel, guess what? It is locked at 0.7 volts also. Again, the diode and R2 are always going to have that same waveform since they're in parallel. So we have taken care of our upswings. So again, in the upswing, we're forward biased. So these are locked at 0.7 volts. And this is 14.3 because that is what's left. Think of this like a combination circuit. If I have 2.7 volt drops in parallel, to make the 15, that has to be 14.3. You guys should already know that from the previous circuits classes. So now let's look at the downswing. So on the downswing, remember, this is my polarity. So that means that the diode is in reverse bias. So when a diode is in reverse bias, what is it? It's open. So remember, this means that the diode is an open. So that means that your source really isn't going to see the diode. Okay? So that means that on the downswing, it's almost like the diode is not even there. So what am I left with? I'm left with a series circuit. So on the downswing, since I have two resistors that are equal value, what's it going to do to this 15 volts? It's going to divide it, 7.5 and 7.5. So on the downswing of things, and I'm going to draw the diode back in there, but remember on the downswing, this is basically open. So that means that this is going to be 7.5 volts, and this is going to be 7.5 volts. So if R2 is 7.5 volts, and the diode is open, that means if I took a meter and I measured from here to here, I would read 7.5 volts. And since this is open, measuring from here to here is the same point electrically. So that means the diode is going to be 7.5 volts. So that is your measurements on the downswing. And again, that's because the diode is open, so the circuit really doesn't see the diode there. It just sees these two resistors, equal value. So I'm going to split the voltage, and then the diode and R2 are always going to read the same since they're parallel. They have that same potential difference. So, on the downswing, I'm going to come down, and I'm going to have 7.5 volts, negative. Now that would probably be a little bit smaller of a waveform if you want to get technical. About half of that, okay? So now, on the downswing of the diode, what do we have? 7.5 volts. And then R2 is the same. So it's 7.5 volts. So that's what my waveforms should look like on the upswing and the downswing when we're looking at the diode facing this way in an AC circuit. So again, on the upswing, it's forward bias. So you see the diode is going to clip nice at 0.7 volts. It's going to be cut off. And then on the downswing, it divides the voltage between these two because this is open, so it's just a series circuit. And then the diode and R2 and R1 are all going to be 7.5 volts. So hopefully that clears things up a little. So what happens when I flip the diode around? Basically what you're going to see is when you flip the diode around is every one of these waveforms are just going to flip. Okay? So let's go ahead, just for good measure, and let's flip the diode around. So let's erase our waveforms here. And let's do it with the diode in the other direction. Now, no reason to erase VS, okay? Because we still have 15 volts. So VS waveform is going to stay the same. All right, so I'm going to erase all of this, and then we're going to observe it with the diode facing in the other direction. And now, let's look what happens. And you will see that it's the same waveforms, just flipped. So looking at the diode now that it's flipped, on the upswing, this is my polarity. So is the anode more positive than the cathode on the upswing? No, it's not. The cathode is positive and the anode is negative. So on the upswing, now we're going to be reverse bias, which equals an open on that diode. It's an open switch. And then on the downswing, when that's my polarity, the anode is positive on the downswing. So that means on the downswing, I'm forward bias. which means that the diode is going to be 0.7 volts. Starting to make sense, right? So again, knowing what the polarity is on the upswing and the downswing plays a huge role in these circuits. Then all you got to do is determine on the upswing, is it reverse bias, is it forward bias? And then draw your waveforms accordingly. So let's look at the upswing. So on the upswing now, this is open. So that means that it's just going to be a series circuit and the two resistors are going to split the voltage. So on the upswing, R1 reads 7.5 volts, R2 reads 7.5 volts. And if R2 is 7.5, then what is the diode? 7.5. So let's draw R1's upswing. So on the upswing, we are 7.5 volts. On the diode, we're 7.5 volts. And on R2, we are 7.5 volts. So now let's look at the downswing. On the downswing, we're forward bias. That's what we have written right here. So if the diode is forward bias, that means the diode will have 0.7 volts. R2 will have 0.7 volts. And what's left on R1 is 15 minus 0.7, which is 14.3 volts. So now, let's draw our waveforms with these numbers. So across R1 on the downswing, we will have 14.3 volts. On the downswing of the diode, we lock nicely at 0.7 volts. And on R2, we do the same thing. So go back and compare this with the previous circuit, and you'll see that this is the same waveforms, just flipped. Okay? So it's easy as that. So that's all there is to this. So now hopefully this makes some sense, because like I said, I did have some questions. The extra resistor threw some people off. Yes, I kind of threw y'all under the bus here, but I did it intentionally. I just wanted to see what your critical thinking skills could be. I know with the online thing, I know in person is a lot different. Okay, so I'm not holding that to you guys. So essentially what I'm going to do is I'm going to repost a worksheet that is similar and let you redo it. Like I said, some of you guys, I've looked through your papers that you submitted, and it was fine. You nailed it the first time. So you did kind of get the point that it is just like the DC, value-wise, it's just both, okay? So hopefully this makes sense. So the next topic that we're going to be diving into is going to be what we call the Zener diode, which is going to be used for voltage regulation. And that video should be coming here in a few days. So again, the next test will actually be administered in the classroom. And then the next two after that will also be in the classroom. That way, any questions that arise, if you're not sure of what I'm asking about something, then you can ask me. You're in person. So I just feel like that's going to be the better route to take, to actually do the testing in person, especially for something that is very visual like this. There's not a whole lot of ways that I can make this multiple choice and post it to Blackboard. So Anyway, I hope that's going to help you guys out. The previous tests are up, graded. They were not bad by any means. So check those out. Check out the feedback. I've told a couple of you guys already through email, please check your old assignments because most of them I do leave feedback. So if you get something wrong, I do leave feedback of why it's wrong and what the right answer is. So make sure you're going back and clicking on some of those old assignments and make sure that you are reading the feedback there, okay? Because that's valuable feedback and it'll help you out for the test once it gets here. Because if you got anything wrong on the worksheet, if you don't know any better, then you're going to do it on the test. So make sure you're checking that feedback. And as always, you guys have my number, you have my email. I sent out the link for the group me chat, so please utilize those things. Ask me questions. And again, next week we'll be back in class, so you can ask away in class, okay? So you guys have a wonderful day, and again, if you have questions, please let me know. See ya.